Welcome students. Today we are going to solve all the questions that has been asked in the mock test 1. So the topic was basic electrical and circuit theory. There are 30 questions. So starting with the first question. Question number 1. The resistivity of the conductor depends on area of the conductor, length of the conductor, type of material, none of this. So as you know, the resistivity is an intrinsic property of a conductor. Okay. So it is an intrinsic property, means it is the property of the material. Means we know R is equal to rho L by A. This rho is the resistivity which depends upon which type of material we are using. So the resistivity of the conductor depends upon the type of material used. So option C here is the correct answer. Next, the resistance of a conductor of diameter D and length L is R. If the diameter of the conductor is half and the length is doubled, means the new length is 12 and the new diameter is D by 2. Okay. So what we know? We know resistance of any conductor is proportional to L by A, that is length of the conductor, and is inversely proportional to the area of the conductor. So primarily R by R nu is equal to L by A into A nu by L nu. Now this is equal to L by A, which is the old area of cross section of the conductor, is given by pi d square by 4, and the new area, which is pi d by 2 whole square by 4 divided by L nu, which is 2L. Finally we get half into 4 by pi d square into pi d square by 16. So finally what we get? We get this to be equal to 1 by 8. That means R nu will be equal to 8R. Hence option D is our correct answer. Now what is the unit of resistivity? You know, rho is equal to R into A by L. So the unit definitely is ohm meter. Okay. So this is correct. Also Siemens is given as option, which is basically the new unit of resistivity. Means the ohm meter is also called as Siemens. So here the answer will be the option number D, that is B and C. Next, question 4. Absolute permittivity of dielectric medium is represented as. The absolute permittivity is generally denoted by epsilon, where epsilon r is the relative permittivity of the medium and epsilon 0 is the permittivity of air or free space. Now what is the relation between these? The relation is epsilon is equal to epsilon 0 into epsilon r. That means the absolute permittivity of a medium is the multiplication of permittivity of free space into the relative permittivity of that medium. So option D here is the correct answer. Now in question 5, it has been asked, if P is the power of a star connected system, then what will be the power of an equivalent delta connected system? So let us draw the star connected system. This is our star connected system. This is the voltage V. This is also V. And this is also V. And let the star connected system is having resistance of R as each resistors. So what is the power of each resistor here? The power of each resistor, this voltage is V by root 3. So power of each resistor will be V square by root 3 whole square by R, that is V square by 3R. So the total power initially P1 will be 3 into power of each resistor, that is V square by 3R, that is V square by R. Now when this load is connected in delta, the scenario will be like this. This is R, 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 and all the voltages between two lines will be V, like this. So here power of each resistor will be V square by R. So total power P2 will be 3 into V square by R. Now you know V square by R is P1, that is 3P1, which is basically here has been taken as P. So this is nothing but 3P. So in this case the total power will be 3 times the previous power. So option number B here will be the correct answer. Next, which of the following are the passive elements? You know that passive elements are those which cannot generate energy or produce electricity. You can take it to be as. Okay. So here the item number 1 is resistor. It only can dissipate electricity. Not electricity, basically the electrical energy. And the bulb, which is basically kind of resistive element in it. So both of these can't generate electrical energy, or they are not basically sources. So A and B both are passive elements. Thus the option C here is the correct answer. Which quantity consists of a unit 1 kilowatt hour? We know watt or kilowatt is the unit of power. Or electrical power. Now if we multiply time in hour with this will basically give us the unit of electrical energy or energy. So option number A here is the correct answer. Inside a hollow conducting sphere, what is the electric field? Means a conducting material is used to make a sphere, then what will be the electric field inside it? Next, question number 8. Inside a hollow conducting sphere, electric field is 0. Electric field is non-zero constant. Electric field changes with magnitude of the charge. Basically inside a hollow conducting sphere, the electric field is 0. So option A is the correct answer. In 9 it has been asked, a conductor of length L has current I passing through it. When it is placed parallel to strong magnetic field B, the force experienced by the conductor will be. Now we know that if a conductor is there which is having a current of I and of length L and is in a magnetic field, and the angle between the conductor, or basically the current passing through the conductor and the field is theta, then the force F is given by B I L sin theta. Theta is the angle between the conductor and the direction of the magnetic field. Now here it is given to be as parallel to each other. So definitely theta is equal to 0 degree. That means F will become 0 as sin theta is, or sin 0 degree is 0. Okay. So option D here is the correct answer. What is the dimensional representation of power? So we know that power is equal to work by time, and work is equal to force into distance. This is equal to, as force is mass in m into acceleration, means length per time square, or length into t to the power minus 2, and distance is again L by t. So we get it to be as m L square t to the power minus 3. So this is the dimensional representation of power, m L square t to the power minus 3. That is option A here is the correct answer. Now Norton's theorem is a way to reduce the network to We know with the help of Norton's theorem, we can reduce any complex network to a current source with resistance in parallel if it is applied to any two terminals AB of a network. So Norton equivalent current source and a resistance in parallel. So the option which is depicting this, that will be our correct answer. Here you can see that option D is basically same as the situation represented here. An equivalent circuit composed of a single current source, parallel resistance and parallel load, because here you are going to connect the load. Okay, so option D here is the correct answer. Next, Coulomb's law of force electric charges closely resembles with, what is the Coulomb's law of force? Mathematically it is the force between two charges is proportional to Q1 Q2 by R square, where Q1 Q2 is the magnitude of the charges and R is the distance between them. So it is basically resembling the Newton's law of gravitation, where the force is proportional to M1 M2 by R square, where M1 M2 are two different masses and R is the distance between them. Okay, so here the option C is correct answer. Question number 13. A capacitor of 40 microfarad is charged to a potential difference of 500 volts. The charge acquired by the capacitor in coulombs is, so what is the relationship between voltage and capacitance and charge of a capacitor? You know that Q is equal to CV for a capacitor. So here you have to find out the value of the charge accumulated. As you know the capacitance, this is 40 into 10 to the power minus 6 and the voltage is 500 volts. So this will be the charge accumulated. 20,000 into 10 to the power minus 6 means 0.02 Coulomb. So option D here is the correct answer. Now a capacitor can be represented by a capacitance and a resistance in parallel. Means generally a practical capacitor is represented like this. The R basically represents the losses in the capacitor. For a good capacitor, this parallel resistance is very high, very low, low or none of this. So definitely you can see when the value of R is high, the current through R will be low, and when the value of R is low, the current through I will be high. So in the first case, I square R is less. So definitely when the value of R is very high, then the losses in the capacitor will be less and we will call it as good capacitor. So the option A here is the correct answer. A voltage of 100 volt is applied to a circuit of resistance 10 ohm. The power dissipated. You know the power in a resistance is given by the square of the voltage across it by R. So here V is 100. So 100 square divided by 10, you will get 10 to the power 4 by 10, that is 10 to the power 3. So C here is the correct answer. Now the question number 16. The condition in Ohm's law is basically when the temperature and other physical conditions remains the same. Okay. So here from the options you can see that the option number A, which is given to be as the temperature should remain constant. So this is the correct answer here. Okay. Because in Ohm's law the constant is the temperature must be fixed and other physical conditions must also remain same. Okay. Next question is the value of the current flowing between points B and C. Now you can see this is basically a bridge circuit. Okay. And here a resistance is connected. So this point is B, this point is C. This is 2, this is 2, this is 2, this is 2. Let this is P, this is Q, this is R and this is S. And you know that for a bridge circuit, if P by Q is equal to R by S, here also 2 by 2 is equal to 2 by 2. So this relationship holds. If this situation happens, then the potential of point B and the potential of point C is same. And when this is same, there will be no current through this branch. So this branch is basically here carrying no current. So the option D here is the correct answer. The nodal method of circuit analysis is based on, you know, in nodal method, basically we try to find out the current entering to a node and current going out from a node. So we basically apply KCL there. Definitely we use the Ohm's law for finding the relationship in between the voltage and resistance is there. So here option number C, that is KCL and Ohm's law, is the correct answer. Okay. Now in question number 19, it has been asked a 20 volt 50 Hz inductive circuit takes a current of 10 ampere at 30 degree lagging power factor. What is the inductive reactance of the circuit? So we know that I is equal to V by Z. Here Z is equal to V is 200. So 200 by 10 is equal to 20 ohm. Now we know that inductive reactance part or XL is equal to Z sin phi, where phi is our power factor angle. So this is equal to 20 into sin 30 degree. That means XL equal to 20 into half, because sin 30 degree is half. So this is 10 ohm. So option D here is the correct answer. Now question number 20. A 24 ohm resistor, an inductor with a reactance of 120 ohm and capacitor with a reactance of 120 ohm are in series across a 6 volt source. The circuit is at resonance, the voltage across the inductor. So as the circuit is at resonance, that means the inductive reactance XL equal to the capacitive reactance XC. So this basically neutralizes each other and the circuit is purely resistive. That is, it is having the effect of only 24 ohm. So the current in circuit will be I equal to voltage by resistance. So this is 2.5 ampere and you have to find the voltage across the inductor. So what will be the voltage across the inductor? Definitely the voltage across the inductor will be VL is equal to I into XL. I we have found out to be as 2.5 ampere and XL is given to be as 120. So 25 into 12. So the voltage will be 300 volts. Okay. Next, a sinusoidal voltage with a peak to peak value of 18 volt is applied to an RC filter. If the reactance at the input frequency is 0, what is the output voltage? Okay. Reactance at the input frequency is 0. As we know that when the input frequency is infinite, then only the capacitive reactance XC, which is 1 by omega C or 1 by 2 pi FC, can be 0. When F is infinite, that means the frequency is very high and it is said to be a low pass filter, means it will not allow a high frequency signal. The signal is of high frequency, so the output will be 0 or the output voltage will be 0. So option B here is the correct answer. Next, a 12 ohm resistor, a 40 microfarad capacitor and a 8 millihenry coil are in series across an AC source. What is the resonant frequency? We know the resonant frequency FR is equal to 1 by 2 pi root over LC for such kind of circuit. So put all the values. This will be 1 by 2 pi into root over of 8 into 10 to the power minus 3 into 40 into 10 to the power minus 6. So this will give you 281 Hertz approximately. So the option B here is the correct answer. Now the question number 23. KCL works on the principle of which of the following? We know, according to KCL, the sum of the currents at a node is equal to 0. That means current entering a node is equal to current leaving that node in an electrical circuit. That is our KCL. So it is law of conservation of charge, law of conservation of energy, both none of these. So definitely when current incoming is equal to current outgoing, current is nothing but the flow of charge. So the option A here will be the correct answer. That is the law of conservation of charge. Next question is, you have to find out the value of this R when the power dissipated in this resistor is 20 watt. Okay. So what is the equivalent resistance here? The equivalent resistance of these two, 5 in parallel with 20, is nothing but 100, that is 20 into 5 by 20 plus 5, 100 by 25. So the equivalent resistance of the parallel branch is 4 ohm and the total resistance of the circuit is 4 plus R. So total current I, if we take it to be I, is equal to 50 by 4 plus R. So the current flowing through this 5 ohm resistor or I5 ohm will be this current I into 20 by 20 plus 5, that is 25. Now we have found out I is 50 by 4 plus R. So this will become like this, 40 by 4 plus R. Okay. Now it has also been given the power dissipated in the resistor of 5 ohm is 20 watt. So this 20 watt will be I5 ohm square into R, that is 5. So 20 is equal to 40 by 4 plus R whole square into 5. That means 20 into 4 plus R whole square is equal to 1600 into 5. That means 4 plus R whole square is equal to 400. So 4 plus R is equal to 20, as we have to take only the positive value. So R is equal to 16 ohm. So option C here is the correct answer. Now question number 25. Here you have to find out what is the current through this resistor. Let us take this I, and here this voltage is given to be as 8 volt, which is the voltage across the inductor. And if we take the voltage across resistor is VR and voltage across inductor is VL, then the input voltage is basically root over of VR square plus VL square. So the input voltage square, that is 10 volt, is equal to VR square plus VL square, which is here given to be as 8. So VR will be root over of 36. That means VR will be 6 volts. So I is nothing but VR by 1 ohm, that is 6 by 1, is equal to 6 ampere. So option C here is the correct answer. You can see that this mock test is specifically designed for junior engineer and assistant engineer examinations of different service commissions. So if you can practice this mock test, you will definitely get benefit from it, and also you will be able to assess your preparation level. So I would say that try to solve this first by your own, and then take a look at the video solutions so that you can analyze that how you are preparing and what is the condition of your preparation, and the way you are trying to solve the problems are the correct way of the solution or not. Okay. So the question number 26, here you can see you have to find out the Thevenin's equivalent voltage and the impedance. So what is the Thevenin equivalent voltage? That means the voltage across these two terminals AB. Okay. So let us take this point and this point where we are trying to measure the voltage. So if the current is flowing like this, then the voltage at this point will be 20 minus 15 into I, which will be same as 10 plus 5 into I. So you will get this I to be as 0.5 ampere. So basically this VAB will become 20 minus 15 into 0.5, that is 20 minus 7.5 will give you 12.5 volts. Okay. So this is your Thevenin equivalent voltage or VTH. Now the Thevenin equivalent resistance, if you want to find out, just redraw the circuit by eliminating the voltage sources by their internal resistances, and it will look like this. This is A, this is B, this is 15 ohm and this is 5 ohm. So RTH will be 15 into 5, that is 75, by 15 plus 5, that is 20. So it will be 7.5 by 2, that means 3.75 ohm. So you can see the pair 12.5 and 3.75 ohm, which is the option B, is the correct answer. Next, the heat generated in an electric heater is attributed to, definitely the heating element in the heater is a resistance which dissipates power, the real power. So the power which is basically consumed in a heater will definitely be true power. That is option B here is the correct answer. If an RLC circuit having a voltage of Vt is equal to 20 sin 314t plus 5 pi by 6 and current of It equal to 10 sin 314t plus 2 pi by 3, what is the power factor? We know that the power factor angle is the angle between current and voltage. Okay. So here you can see that the angle of voltage is 5 pi by 6. which is equal to 150 degree, and the angle of current is 2 pi by 3, which is 120 degree. So the angle between voltage and current is just subtract 120 from 150, 30 degree, and definitely the voltage here is ahead of the current. That means the current is lagging the voltage, and the power factor is cosine of the power factor angle. So the power factor is cos of 30 degree, that is root 3 by 2, and lagging. Now we know root 3 by 2 is nothing but 0.866. So option C here is the correct answer. Next, in question 29, it has been asked that the inductive reactance of a coil having inductance of 0.1 Henry will be. We know that inductive reactance XL is equal to 2 pi FL. The L is given to be as 0.1 Henry, and we know that in India the frequency of supply is generally taken to be as 50 Hz. So just put all these values, you will get XL to be as 31.4 ohm. Okay, so the option C here is the correct answer. And finally the question number 30. The RMS value of the voltage given by 4 plus 2 sin omega t plus root over of 14 sin 2 omega t volts will be what? Now for this kind of question, the VRMS is given by root over of the DC value square. So this plus the square of the RMS value of each of the sinusoidal components, that is 2 by root 2 square plus root over 14 by root 2 square. So this will give you root over of 16 plus 2 plus 7. So this will be equal to root over of 25. So here the RMS value will be 5 volts. That is option number B. Hope all of you have understood all the questions and how to get the solution of these questions. So I think all of you will definitely get benefited when you will practice. So in each week I will upload a mock test paper, and after 2 or 3 days of uploading I will upload the video solution. So practice this mock test and watch out the video solution I am providing. I think definitely you will be able to crack different competitive examinations. Okay, so thank you. Thanks for watching.